Exhausting root partition space. A root partition space exhaustion attack is a type of denial of service, DOS, where an attacker, or a malfunctioning process, intentionally fills up the primary storage partition, / of a Linux or Unix-based system. When the root partition hits 100% capacity, the operating system loses its ability to write temporary files, update logs, or manage sockets. This usually leads to system instability, service crashes, and in many cases, a complete system freeze. How the attack works. Most Linux systems are structured with a root directory that houses critical system binaries, configuration files, and crucially log files. An attacker targets directories that are not mounted on separate partitions. Common targets for inflation, /var/log, the most common target. By generating massive amounts of log data, example through failed login attempts or malformed web requests, an attacker can swell log files until the disk is full. /tmp, if permissions are too loose, an attacker can write massive garbage files here. /var/spool/mail, flooding local user accounts with mail. The consequences when the root partition is exhausted. The blast radius is significant because the kernel and core services rely on that space to function. Impact area result. System logs syslogged or journaled fail, meaning you lose visibility into what is happening on the server. Authentication. Users may be unable to log in because the system cannot write to /var/run/utmp or create session files. Databases. Services like MySQL or PostgreSQL will crash or enter read-only mode to prevent data corruption. Cron tabs. Scheduled tasks may fail to execute if they need to create temporary output files. Prevention and mitigation. The best defense is a proactive architecture rather than trying to delete files after the crash happens. Partitioning schemes. Always mount high-growth directories like /var/home and /tmp on separate logical volumes, LVM. This ensures that if /var fills up, the core /partition remains functional. Log rotation. Use log rotate to compress and delete old logs automatically. Quotas. Implement disk quotas to limit how much space any single user or process can consume. Reserved blocks. By default, Linux reserves about 5% of disk space for the root user. This allows an admin to log in and fix the issue even if a standard user has filled the disk. Fun fact, if you're ever stuck in this situation, a quick emergency fix is to truncate a large log file using /var/log/heavy_file.log rather than deleting it, as deleting a file currently being written to won't actually free up space until the process is killed. How to classify root partition space exhaustion attacks. Primary classification. 1. Resource exhaustion attack, a subtype of denial of service. This attack's goal is to consume critical system resources, in this case, disk space, so that the system can no longer function safely. Why? When the root file system fills up, the system may fail to write logs, fail to start or stop services, crash system daemons, break authentication mechanisms, fail to spawn shells or pseudo corrupt data or configs. This leads to a local or remote denial of service which matches DOS style behavior. Detailed taxonomy. Placement category. Denial of service. Rightward arrow. Local resource exhaustion. Rightward arrow. Disk exhaustion attack. This sits alongside other resource exhaustion attacks like CPU exhaustion, memory exhaustion, file descriptor exhaustion, inode exhaustion, process table exhaustion. Subtypes of disk exhaustion attacks. Depending on how the attacker triggers the space exhaustion, it may map to one of the attack styles below. 1. Local resource exhaustion attack. An attacker with some level of system access, example shell, compromised service account, intentionally fills disk space. Example, writing huge files into /tmp, /var/log, /root, or any mount that shares the root fs. Dropping endless logs via a compromised process. 2. Application layer resource exhaustion, logic abuse. An attacker abuses an application endpoint that writes to disk. Examples, sending huge payloads to a file upload API. Repeatedly triggering a function that logs massive error messages. Causing uncontrolled log rotation. 3. Remote DOS via log amplification. Attacker sends crafted requests that cause the server to write excessively large logs. Examples, triggering verbose debug logs via malformed HTTP requests. Spamming auth failures to fill /var/log/auth.log. This is effectively a log amplification DOS. 4. File system level attacks, quota abuse /inode exhaustion. Attackers may fill, inodes, exhaust file count even if disk isn't full, user quota shared storage pools. This is also categorized under DOS rightward arrow file system exhaustion. So the general classification in your taxonomy is, network attacks, denial of service, DOS, resource exhaustion, disk exhaustion attack, root partition, log amplification attack, file system inode exhaustion, application layer storage exhaustion.